You know, in today's world, we're creating just a staggering amount of data every single second. But have you ever stopped to think about how the massive apps we use every day, the ones serving millions of people at once, actually manage all that information without just crashing? Well, we're about to pull back the curtain on that.
Seriously, think about it for a second. When you're binge watching your favorite show, or checking your bank account, or trying to book that last-minute flight, you're just one person in a sea of millions doing the exact same thing at the exact same time. How on earth does the tech behind it all keep up?
The answer, and this might surprise you, isn't just about throwing more powerful servers at the problem. Nope, it's about a completely different way of thinking about and storing data. It's a fundamental shift away from the old way of doing things towards something that was literally built for this crazy, real-time world we live in. Okay, so to really get why this change is so important, you first have to understand the sheer scale of the challenge we're facing. We're not just talking about a lot of data. We're talking about a constant, overwhelming flood of it. I mean, every smart device in your house, every single tap on your smartphone, every single financial transaction happening around the globe, it's all generating data that needs to be processed right now. The traditional databases, they were designed for a much, much slower pace. And when you hit them with this kind of volume, they often become a huge bottleneck, grinding everything to a halt.
So let's take a step back and look at how things used to be built. And to make this really clear, we're going to walk through an example you'll definitely recognize.
All right, let's pretend we're building a hotel booking website. If we use a traditional database, what's called a relational database, our first instinct is to get everything super organized, following a very specific set of rules.
Now, the guiding principle here is this idea called normalization. The main goal is simple: don't repeat yourself. You want to avoid duplicating information at all costs. So you create these nice, separate, specialized tables for each thing, making sure there's only one single source of truth for every little piece of data.
So, for our hotel app, this seems totally logical, right? We'd have one table for all the hotel details, another one for all the different rooms in those hotels, a separate table for guest info, another one for nearby attractions. You get the picture. Everything is neat, tidy, and has its own special place.
But, and this is a huge but, here's the catch. When a user comes to our site and wants to see a hotel's details, and its available rooms, and the cool stuff to do nearby, all on one page, well, your app has to go fetch data from all those different tables and then stitch it all together. This operation is called a join. And that one word, join, is the key to understanding where this whole beautiful model starts to fall apart.
This super organized system, it works great when you're small. But what happens when our little hotel app suddenly becomes the next big thing? All of a sudden, you've got millions of users hitting your website. The number of hotels, rooms, and bookings just explodes. And that neat, tidy little model we built, well, it's now under an incredible amount of pressure. And this is exactly where it breaks. Those joins that were so simple before, they become painfully slow when you're trying to connect tables with millions and millions of rows. Trying to scale the database to handle more traffic often means taking the entire website offline from maintenance. And what about adding a simple new feature like a geolocation tag for a hotel? It turns into a massive, risky project. The model is just too rigid to keep up with the real world.
So, if the old way can't handle the speed and the scale of the modern internet, what's the alternative?
And that brings us to a whole new kind of architecture. So let's meet Apache Cassandra, a distributed database that was designed from the ground up to solve these exact problems.
Now, what's really fascinating here is the fundamental difference in how they're built. Traditional databases usually have a master-slave setup. You have one main server, the master, that's in charge. If that master server fails, guess what? The whole system can go down. Cassandra, on the other hand, uses a masterless or peer-to-peer model. Every server in the group is equal. There is no single point of failure.
And this right here is the biggest advantage. Instead of having to buy one giant, super expensive master server to handle more traffic, you just add more cheap standard servers to the group. The system is smart enough to automatically spread the workload across all of them, and you can do this without ever taking your app offline. Zero downtime. That's a huge deal.
So, what does this new way of thinking mean for our hotel app? Well, it means we have to completely flip our design philosophy on its head.
Okay, this is the most crucial point, so listen close. With a traditional database, you design your tables first, then you figure out how to ask them questions. With Cassandra, you do the exact opposite. You start by figuring out the questions, the queries your app absolutely needs to answer. Then you design your data specifically to answer those questions as fast as humanly possible.
For our hotel app, these are our most important questions. What hotels are in Bangalore? Show me everything about Hotel H123. Can I see the rooms for that hotel? And can we update the prices instantly when things get busy?
And here is where the magic happens. We literally create a table for one purpose, to answer the question, get all hotels in a city. We use the city name as the partition key, which is just a fancy way of telling Cassandra how to group the data together on the disk for lightning-fast access. And notice this, we're breaking that old rule. We're duplicating the hotel name. It's called denormalization, and we're doing it on purpose to create a pre-built answer. So when the question comes in, the data's already perfectly organized. No joins, no complicated lookups, just a ridiculously fast answer.
This whole query-first, denormalized approach, this is what makes systems like Cassandra the backbone of so many of the huge applications you use every day.
And this isn't just theory, This tech powers massive, real-world systems in pretty much every industry you can think of. From IoT platforms that are swallowing data from millions of sensors to fintech systems that need to process your transactions instantly and securely, Cassandra is what gives them the scale and speed they need to work.
So, the main takeaway here is that for any application that absolutely cannot afford to go down and needs to handle a tsunami of incoming data, Cassandra's architecture is the perfect foundation. It's resilient, it's always on, and it's incredibly fast. And for you, as the user, that means your favorite streaming service doesn't start buffering on a Saturday night, and your banking app shows your latest transaction instantly with zero delay. This big shift from those old centralized models to these new distributed query-driven ones is absolutely essential for building the next generation of apps. And it leaves us with a really critical question to think about. As this real-time data deluge just keeps getting bigger and bigger, is the technology you rely on actually built to handle what's coming next?